This video tutorial describes how to use the feedwater heater program for the calculation of feedwater heaters. On loading the program, a window like this will appear which contains a series of input fields where the input data can be specified. All input fields must be completed before the program can perform the thermal calculation. To help understand each input field, an integrated instruction manual can be accessed by clicking on the Instructions button. The purpose of the other buttons will be covered in a moment. The instruction manual contains a brief overview of the program. And a description of the information required in each input field. We will now look at the functionality of the buttons on the previous page. The Results button opens the Results page. The Results page is populated after executing the thermal calculation and includes a reprint of the input data and the results of the thermohydraulic calculation. This results sheet covers inputs and results. The Drawings button opens the Drawings page. The Drawings page contains sketches of the specified feedwater heater configuration, one with the principal dimensions, and one showing the baffle and tube support arrangement. Please note that these drawings are generic representations of each feedwater heater configuration and are not drawn to scale. Here I'm navigating between the input data, results, and drawing pages. The final part of the instruction manual includes windows with inputs and results for a mechanical calculation giving thicknesses and approximate weights, and also a series of recommendations which should be considered during realization of the mechanical design. Please note the instruction manual can be printed if desired. Returning to the Inputs page, we will now review an example case. Rather than specify each input field, I'm going to load the input data from an existing saved case. In order to do this, I simply click on the Load File button and select the desired example file. Once loaded, I can click on the Units button to select the desired units that I want to work in. As we can see, this heater has a desuperheating zone, a condensing zone, and a subcooling zone. The heat transfer coefficient will be calculated according to classic literature correlations, denoted by code 1 in this input field here. The alternative, code 0, is a proprietary method based on the program developer's 40 years of industrial experience designing feedwater heaters. In addition to the correlation selection, the tube characteristics, diameter, thickness, and material have all been specified. These tube dimensions and the specified desired velocity of the feedwater determine the dimensions of the unit and the associated pressure drop. The unit installation and type of heater are also specified here. The final three input fields allow coefficient multipliers to be specified, which allow indirect specification of the exchanger coefficients if necessary. To run the calculation, we click on the Run File button. To view the results, we must click on the Results button, which takes us to the results page. The input data is represented on the left of this page, with the calculation results on the right. The calculation results include the heat duty, logarithmic mean temperature difference, heat transfer coefficient, and heat transfer area for each of the zones in the heater. Also reported here are the tube side pressure drop, intermediate temperatures, and drain cooler approach. The principal dimensions of the heater, diameter and length, are shown, as are the dimensions of the connections and internal casings. The dew point temperature is also given so that this can be compared to the calculated steam exit temperature leaving the desuperheating enclosure. We can also see the quantity of tube support plates and the approximate shell side pressure drop of each zone. If we close the results page and then click on the Drawings button, we access the Drawings page, which shows sketches of the heater configuration with overall dimensions. The heater in this case is horizontal, and we can see that the dimensions reported here are the same as those reported in the results page. If we close this initial Drawings page, a sketch of the baffle arrangements is shown. In this case, the shell side flow orientation in the drain cooler is up and down. The flow in the desuperheater enclosure is side to side. It should be well understood that the final dimensions and the number of tube support plates must be defined by the mechanical design, since these parameters influence the mechanical integrity of the unit, especially the tube vibration considerations under excess duty conditions. In the Inputs page, we can access the Print button. Which will print the results and corresponding drawing pages. Cases can be saved by clicking the Save File button. As an example, we can change the heater type by a number 1. Save the new case under a new name. Once saved, we can check the impact of this modification by clicking the Run File button and subsequently the Results button. Clicking the Drawings button, we can see that the orientation of the sketch has been rotated to a vertical heater type with some minor modifications to the overall dimensions. To allow mechanical calculation, click the button named like this. On the New Inputs window, fill out all of the required data according to the material characteristics, and then use the main buttons to run the mechanical calculations, review the results, print, load, etc. in a similar way to the main results window. To finish our session, we close all the windows and exit by clicking on the Exit button.